All right, I'm going to start with our giants of female. Diane Lemaire. Diane was the first woman to graduate as a Bachelor of Mechanical Engineering from Melbourne University in the 40s. So the first woman to get engineering in Melbourne. Interesting story. She had to complete a housewifery test. This is to show the times of how times have changed. She had to do that in order to stay at the Janet Clark Hall residence, but she actually failed the test. She didn't even know how to boil an egg, apparently. Anyway, luckily they let her stay, and she went on to get her degree, but obviously destined for better and bigger things than that. Over her career, her achievements included being the recipient of the Amelia Earhart Fellowship in the UK in the 50s. She went on to get a Master of Science at Cornell University in the 60s in the US, and finished the majority of her career back here in Melbourne, Australia, doing aeronautical research. Her legacy, though, she's bequeathed a substantial estate to the University of Melbourne's Faculty of Engineering, of which a Diane Lemaire scholarship is open to female PhD students who have completed the equivalent of 6 months candidature. But today we're here to talk about developing LabVIEW real-time using DQMH and how we can do that more successfully. My name's Chris Farmer. I work here in Melbourne, Australia for a company called Widen Software, and we do LabVIEW, all things LabVIEW. Awesome to be part of this 24 hours of LabVIEW session. I've been excited and petrified at the same time. But now that we're here, it's awesome. So well done to everyone who's presented so far. For those who don't have an attention span and just want to do the too long didn't watch, well, here's the shortcut. Actually, no, you can wait till the end. All right. First of all right, what we're here to do is talk about real-time development. Now, I've done a couple of projects this year where we've had to do some real-time applications. Widen Software, we're a big DQMH user. We're a trusted advisor of DQMH. As Jörg would put it, DQMH is our hammer and everything's a nail. So this is all about some of the lessons learned that we've experienced with trying to get DQMH effective on real time. The short answer is it works really well, but there's a few things we learn along the way. The first lesson I want to teach everyone is make sure your modules are up to date. All right, it's got to be at least DQMH 5 or above, because there were some changes in DQMH 5 that meant before DQMH 5, LabVIEW real-time and DQMH didn't work perfectly. You had to create some workarounds. The workarounds worked, but now with DQMH 5, it's a lot easier. I got stuck on a problem only 3 months ago. I'd ported across a DQMH module that was old. It was DQMH 4, and it hadn't been updated to DQMH 6 level yet. And here I was trying to bash my head against the wall, trying to work out why it didn't work. It's because it was an old DQMH module. So first thing you should do is, if you're bringing in any modules from around old projects, make sure they're up to date. You do that by using the DQMH validation tool, which I'll show you in a second. So that's really important. So make sure your DQMH modules have been updated to the latest version. Otherwise, you're going to hit some trouble. So to demonstrate that, I've got a little video here. So what we got here is a simple project with one DQMH module, and it's not playing. There we go. Took a little bit to get started. All right. We're going to go and we're going to open the validate tool that you just saw there, right? And what we can do is we can validate a single module or all the modules in our project. And This DQMH validate tool is really easy to use, and I recommend you use it regularly regardless of whether you're doing real time or not. But what we've got going on here is we're just analyzing this module. Now, this module I've dragged across from an old bit of code. It's DQMH4. It's going to have some issues. And this is the issues that we've been presented with here. So the validation tool found all these issues. But the important one I want to point out is this start module issue. It's found that, yeah, it's using the old start module approach. DQMH5 has improved that. And yeah, it's now able to be fixed. So you just hit the fix issue button, done, it's fixed. It's now brought up to the right level. You can basically then step through all the other issues and bring them all up to the other level as well. And yeah, look, we're going to revalidate it just to rescan it, and you can see that issue that I addressed earlier is now gone. I'm not going to go and fix all those other issues, but the point is bring that module up to date. All right, so that was the first point. Make sure everything's up to date with your DQMH. Next thing, plan out your project. I mean, this is not a real-time specific thing. You should do this anyway. Plan out your project. Some things to be mindful of is learn about your target and your environment. Has your target got an embedded user interface? That will change how you code up your DQMH in real time. Other questions like how much memory or disk space do you have on this compact Rio or real-time target? And consider things like what IT restrictions are going to block your application. That's always going to get in the way. You know, like some organizations have a fairly tight firewall system, and you've got to make sure that your application can get through the right channels. So another thing to keep in mind is I like to keep my DQMH structure pretty simple for real. We do it pretty much in Windows as well, but for real time especially. You don't want to overdo it with the DQMH module layers. It gets really hard to debug and trace. A couple of years ago, we did a project and we got a bit fancy. We had a module at the bottom that was talking to the instrument. Then we had a central processing module that sat above that. And then we had a user interface module that sat above that. Then we had a high level module, and you're sending messages all the way down and then all the way back up again. It was hard to debug. Some of those modules were clonable. It was a bit of a nightmare. So don't go overboard in your module structure, especially real time. Also keep in mind there are limitations with real time, and that's nothing to do with DQMH, that's just real time. So what are some of those real time limitations? Well, all of these features here are unsupported. In particular is this one here, SubPanels. We love using SubPanels here. You can't use SubPanels on real time. And debugging reentrant BIs is not a good, easy thing to do, or it's not possible on real time. So that one will catch you out. Another thing to think about, to clonable or not to clonable. Clonables aren't debuggable in real time because of what I just said. Reentrant clonables, you can't debug them. So my advice is to consider using them carefully. For a while there, I had this attitude, oh, let's make everything clonable, because then you don't have to, it's diverse, it's flexible. But for real time, like I've gone away from that idea. I think you just want to stick to singletons where possible. That doesn't mean you shouldn't use a clonable when a clonable is called for. It's just I wouldn't just choose clonables over singletons because that makes things easier. It doesn't in real time. And it's because they can't be debugged. And the reasoning is on that knowledge base there. Basically, yeah, BIs executing on real-time targets do not include front panels. and LabVIEW cannot open reentrant VI copies for debugging. All right, so yeah, clonables are okay, but don't overuse them. So that was plan out your project. You've thought about a few things. Now let's talk about user interfaces. Well, there's a couple of different options now. Back in the day when I was writing Compact Field Point in 2003, you only had one sort of way to have a user interface, but it's grown a bit since then. The first one is an embedded user interface. Embedded user interfaces are only available on selected RT targets. I'll mention which ones they are in a minute. And they're also great for standalone systems. Another option for a user interface is a remote panel server. Now, I think they're on their way out. They're dependent on deprecated tech, and the IT departments hate the remote panel server because you have to tell them you need to use Internet Explorer and Silverlight, and they don't like that. But I think they're still a really useful tool. They work okay, and I think they're really useful for not only for being a user interface, but for debugging too. The traditional way of a user interface is that you have a LabVIEW Windows application and you're communicating via real-time to Windows through a TCP/IP link. There are lots of options for that. A lot of the LabVIEW examples already have this stuff worked out, but you've also got Hamplesoft have a generic networking DQMH module template you can download from their GitLab page. And also, we've used simple messaging to great effect, a very basic TCP/IP simple messaging toolkit. You could also use shared variables and a host of others, network streams, all that, or just raw TCP/IP. But the fourth one is Systemlink. It's the newbie. Systemlink Cloud is also a good option. It's very easy to send data straight to Systemlink for, data management, visualization, and insights. So let's start with embedded UIs. So an embedded UI is basically you've got, say, a compact Rio and you've got a display plugged in to your real-time target. And the display, it's just basically like you're sitting at a Windows computer or a Linux computer, even more so. So you can basically write your application almost like just a standard Windows app. You basically plug in a display. It could be a touch screen display, works really well. And really good for applications for this is sort of like a standalone application that requires user interaction. So it's like an inline asset monitoring application or maybe a control panel, for something. But if you're going to shove a compact Rio in a cabinet away, remotely distributed, and there's no user interaction, then an embedded UI is not required. Some of the real-time targets that have a embedded UI are industrial controllers, a few of the 903 or 904X compact Rios, a few single board Rios, and the rest of the compact Rios don't have them. There's not a definitive list that says this has got an embedded UI or not, but there are two things that govern it. If the Rio has an Intel x64 chipset and if it has a display port, whether that's mini display or VGA or USB-C with mini display capability, then you can use an embedded UI. Just go to that really short URL I put up there for you to go and find out more. What are the differences? There is some interesting differences with embedded UIs. With embedded UIs, you can use user interface and dynamic events. But without, you can only use the dynamic events. The user interface events is like button presses on the screen, and dynamic events are like programmatic events. So you can't use UI events without an embedded UI. You can use your regular DQMH API Tester VI on embedded, but you cannot use it if you're using not embedded. You can just plug a display in to view your module front panels like you normally would on your Windows desktop, But for not embedded, you've got to use one of those other options I talked about earlier. One of the big limitations, as I said earlier, is SubPanels. You can't use SubPanels. We use SubPanels a lot. You can't use them on RealTime, unfortunately. They're not supported. And so if you're going to do a nice embedded UI, you know, consider your front panels carefully. Don't try and squish too much into a single front panel with a zillion tab pages. It's you paint yourself into a corner. All right, so that's embedded UIs. Another UI that I spoke of before is Systemlink. So I'm going to give you a real quick demo about Systemlink. Systemlink, if you weren't aware, and this is really cool, I think, if you've got a valid LabVIEW subscription right now, you've likely got a systemlinkcloud.com account. All you have to do is go to systemlinkcloud.com and sign in with your NI credentials, and you'll have access to Systemlink Cloud. And it can easily, Systemlink Cloud is like a cut down version of Systemlink. You can read tag data, build basic visualizations, store files, host web VIs. All right, here's my mini little demo. I'm taking DQMH out of the picture for this one for the moment, but basically what I'm trying to do here, we've got a real-time compact Rio. It doesn't have an embedded UI, by the way. It's an older model. If we go to the examples, out of the box there is an example there. It's called write tags. But what we'll do, if we do a search for Systemlink, and we can open up multiple tag writer, and that gives us an example. What I'm going to do here, I'm going to just grab this code. I'm going to bring it into my real-time target for this example. This example, it just writes data to a couple of Systemlink tags. And when we get the front panel up, you can set how you're going to connect with Systemlink. We're going to use the Systemlink Cloud API key. So what I need is the Systemlink Cloud API key. So what we're going to do now is we're now going to go to Systemlink Cloud. So bring up a web browser, systemlinkcloud.com, log in. And as I said before, you just use your NI account details. So I'm just signing in as my NI account, and I'm now into systemlinkcloud.com. And the first thing I'm going to do is go to the menu, and I'm going to go to security and create an API key. Right, that's pretty easy. We created an API key, and we're going to label that GLA Summit 2021. Copy the key and update that. So we've now got an API key. I'm going to jump back now into LabVIEW and paste that key into the front panel there, and we're going to run that. And this is going to deploy. So we're deploying this application onto the real-time target. Takes a few seconds, and it's running. And what we're doing is we're generating two random numbers, basically, inner temp and outer temp. And this code, basically, we're creating two Systemlink tags over here on the left, and then in our while loop over here, we're just writing to those tags two random numbers. And we're just displaying it on the LabVIEW display so we know what we're doing. But if we go back into Systemlink now, we can go to data tags, and we'll be able to see the two tags. So there's the data that we're now writing to Systemlink. They just appeared automatically. LabVIEW's basically created them on Systemlink and put them up there. If we refresh, you can see the values update. So now we've got data running from a compact Rio being written to systemlinkcloud.com, and we're going to go to visualizations dashboards, and this is a nice little feature of Systemlink Cloud. I'm going to create a very basic dashboard here, and just create a freeform dashboard. We're going to just get a chart. We're going to throw it on the canvas, and you can see down on the left there's the two tags that we've just created. We're going to drag them onto the chart. And then I'm going to hit the play button. And there it is. There's data coming in. So that's running on the real-time compact Rio in our office, and it's getting up to Systemlink Cloud. And the last step in the puzzle is I'm now wanting to share this with somebody. So I go back to the dashboards and go share. And for the purposes of this, I can just say everyone can access this, but you can obviously be a bit more tighter in who you want to share your displays with. And I've copied that, and there it is. Now, Stuart is just going to paste in for me into the chat the link. So if you want to have a look, it's still running, right, Stuart? It hasn't crashed or something. Yeah, click on that, and that's my real-time compact Rio. It's actually, yeah, it's producing that data right now. It's just random number generator, but you can see that running. In fact, yeah, so there you go. That's like, you know, to get something really up and simple and running, Systemlink Cloud's really effective. You can also, what I haven't shown you here is you can put a web VI on there as well, and create your own web VIs using the G Web Development Suite. All right, so that's Systemlink. Now, I'm just diverting from user interfaces for a minute because it's a good time to talk about API testers. I will come back to another user interface example in a minute. But I want to talk about real-time API testers. Now, if you know DQMH, you know that you'd be creating a tester every time you create a module, you got a tester, and you maintain that tester to use it as a way of testing and isolating your module, a really powerful tool of DQMH. But you don't get a real-time tester created by default. You've got to create it yourself. It uses, the real-time tester is going to be using a polling method of button pushes because it can't use UI events. Remember, this is because we don't have embedded UI. Well, this is when you would need it. You simply create it manually. There is an option in the DQMH menus. And what I do, I like to put a big text in yucky colors over the standard API tester to remind me I'm not using the standard tester because it's going to create another tester side by side. But it pays to keep both the testers maintained and up to date, because if you've got a module that could potentially be used on Windows or real time, you kind of want to keep them both up to date. And it's good practice not to delete the default tester. Don't delete the tester. Has anyone had a chance to look at whether it's still pumping any data out on my link that I've just put in the chat? Oh, Ruchi. G'day, Ruchi. All right, so let's create a real-time tester. Thanks, David. Yes, it is live. All right, so we go to Delacorp DQMH real-time, create RT tester. Now, this is another example. I've created another module here that's built on what we showed you before, where it's writing the multiple tags. But we select which module we're going to create a tester for, and then we go ahead and hit OK. While it's doing that, yeah, this module, it's a DQMH module based on the write multiple tags example I showed you earlier. So this is what the real-time tester looks like. It's already figured out that we had a couple of requests that I created in my public API. I've got update temperatures and set up cloud API. So it's picked those up and brought them in to this tester. And if we look at the block diagram, you can see there's a 100 millisecond timeout on that event structure, because every 100 milliseconds, we're going to poll all those buttons, bundle them into an array, and work out which one was pressed. And this is the old way. You had to do it back before DQMH 6, DQMH, back LabVIEW 5 or 6, where you didn't have event structures. They were the good old days. So I'm just updating my my tester front panel here with the required controls. and that should make my tester not be broken anymore. That's right. I'm going to do a bit of a tidy up here. Look at that, super quick. Okay, so that's my tester. So I've created a real-time tester. And you can see in the project there, it's sitting side by side with the original tester. And that's what the original tester looks like. And I'm going to slap that on the front panel so that it reminds me, don't use that tester. Use the other one. That's just for me. You can do it however you want. So we're going to deploy that. And now that's, I've got to jump to the next video. And I can skip a bit of this. Okay, so we're running. So it's now running on the real-time target. So you notice that you can't show the block diagram. You can't show the front panel. Normal things you can see on the tester. You can't do that on the real-time tester. It's just not something that's supported. So we're going to run the new module instance, and we're going to send some requests down. We're going to set up the cloud API key. Right, so this is, like I said, this is based on the example we had earlier, but I've now created a DQMH module out of it. And just to make sure, I've brought back Systemlink Cloud, and I can see that the data is being updated on here. If we refresh that, come on, video me, refresh. So, yeah, it refreshed. Okay, so now I can just write data. Here we go. Refresh, and there's the data being updated. So we know that's still working, but now we're running it as a DQMH module, and what I'm doing is I'm actually running it via the tester. So this is still in LabVIEW mode. I haven't created an executable or anything. I had to go back into the dashboard because now that I'm running it through a DQMH module, the tags have been renamed. So I've got to use the new tags. The tags are sort of based on the VI. All right, so we'll just skip past a bit of this. I'm basically dragging them on, and we can get data coming in. So yeah, that still all works fine. So there's my real-time tester. All right, so that's how you create a real-time tester. We're going to come back to the real-time tester in a little bit because it can be very useful, especially when you're testing clonable modules, because you haven't got the same debugging ability, like I said earlier. Now, one of the other options is remote panel server. I find it really handy to use. I always use it. I find it it's a handy user interface, and just as equally a handy debug utility. To access a remote panel server, you just need the runtime engine on the viewing PC, but you can't really run it on a non-Windows computer. It is based on deprecated tech, though. I don't know how much longer it's going to last. So what I'm going to do now is show you how to do a remote panel server. This took forever for me to figure it out, and I know Stuart here, who's sitting right beside me, had spent copious hours trying to get it working. So this is how you do it in 5 minutes. All right, what we do, remote panel server, what we're going to do is we're going to go to the tools, and we're going to, the video is not working again. Oh no, it's running over there, good. Sometimes the video doesn't run. Apologies, everyone. All right, sorry. Okay, what we're going to do is select Tools, Web Publishing Tool. And I'm going to go and select the top level VI that I want to use. I picked main VI, but that was wrong. So I'm going to go and do it again. And this time I'm going to pick the tester, because I'm going to make the tester my top level VI that's going to be my user interface for this example. And then we're going to So we've selected our top level VI. We're going to go next. We're going to give it a title, GLA Summit 21. It's going to be a temperature chart. And we're not going to bother with a footer. So I'm going to save my web page there next to the project. I'm going to what this is going to do. It's going to create a HTML file for us, and that's what it kind of looks like in the preview pane. All right, so we've now created a HTML file. We're going to add that file to our project, and that's in there now. We're going to go and create a build spec. So I haven't done this yet, so this is our first time we're going to create a build spec. We're going to need the tester as a startup VI, and we're going to need the HTML file included. We're going to need to create a new destination, call it www directory. Now, pay attention to this path. I'm going to pause it, right? That's the path. This is for Linux real-time targets, by the way. It's different if you're using older FarLap or VxWorks ones. But that is the path of where the www pages are supported. You're wondering how I got that. It's written somewhere in a knowledge base and in the LabVIEW help, but that's really important to note. All right, so then we need to say that the network comms file, the HTML file is going to go to that directory. And if I do a preview, just to make sure it all's there, you can see the two paths, right? So there's going to be a exe, and then there's going to be the HTML file. So that's my build spec done. I'm going to edit this. I'm just going to show you what this file looks like. I just wanted to raise an important point. This is the HTML file. You can see the VI name that we're selecting as our top level VI. If that VI was in a DQMH module or a library, any library for that matter, you need to preface that VI name with the library name as well. So it would be, if it was part of the network comms library, it would be networkcomms.lvlib:VI, and then the name of your VI. It's a really important thing to remember. The next thing we need to do is make sure we've enabled the remote panel server. So we go into the properties of the target and we do that. And then I'm going to connect, or I'm going to deploy. So when I've done that, what that's doing is that's deploying all those, that remote panel server setting, that's deploying that to the target. That's an important step. That one caught me out. Spent hours trying to work that one out. This is all documented on an NI knowledge base article. And then, so we're prepared now. We're going to build our exe. So our exe is going to be that API tester. And we're going to deploy a web page. And so now that that's done, we right click on it and run as startup. Windows keep flying off to the other screen, but proceed with reboot. Yes, we've got to log in. And it reboots. So now the Rio has rebooted. You can use NIMAX to confirm the status. So it's disconnected at the moment. But now it's back up and running. Yes, I have hit pause a few times during this video. But I now bring up Internet Explorer. That's not Chrome, that's not Edge, and that's not Safari. That's Internet Explorer, because it won't work on anything else. Or it might work on Firefox. Did it work on Firefox? Okay. So the address there, let me pause for a second. The address, that's the IP address of my Compact Rio, :8000, which is the port number, / networkcommstester.html. And you can see that it's, the web page is opened up, and you can see my front panel of my tester. You got to request the control of the VI, and we're going to run a new module, and we're going to set up the cloud key and just run it like we were before in LabVIEW. We're updating temperatures, and you can see that they're being written to a chart there. And that's all working, and so that's running as an executable. and we're viewing the user interface through the remote panel server. And just to make sure, I brought up the Systemlink cloud to make sure it's still reading in data. Sam's pointed out there is a setting that would automatically request control. That is correct. That was one of the settings in the HTML file. Yeah, so there you go, that remote panel server. Video's paused again. Yeah, anyway. How am I going for time? 12:36. Is that the video I've already done? Yeah, it is. All right. So that's another user interface. So remote panel server, to me, I think still really valuable for debugging, like you just saw. So yeah, I recommend being able to take advantage of that when you're developing real-time applications, regardless of whether it's DQMH or not. Now for a bunch of random miscellaneous tips. Use status updated broadcast for debug. I use this a lot. I think it's critical for when you're doing clonable modules. Right, the clonables are not debuggable. You can't jump in there like you're used to. So you've got to come up with some other techniques. So plan to use status updated in your clonables early on. I like to just put them everywhere. I stick them in after every message handling loop call. I put them in some or all of the event loop, handling loop, or even helper loop calls, just so I can see what's happening, right? It tells you a story of what's happening. It's the best way to visualize it, and it's really useful for that reason. And you can use the real-time API tester, just like we were showing you then, to see what's happening. And so I'm going to demonstrate that right now in another little demo here. So if you look at this code here, this is under the hood of the module we were just working on. In my update temps case, I'm just dragging in a number of different indicators and controls. It's pretty messy and scrappy, but I'm just using the bundle function to variant, using the JKI, flatten to JSON string, and writing that to the status updated VI, the broadcast VI. That's going to broadcast to any broadcast listeners. I'm using that in a number of other places around my application as well. So I've made that change. I'm going to rebuild it, and you'll see how that comes across. Just skip a bit. And all right, so now that we've rebuilt it, rebooted it, we're running again. This is the same as before. Request control, run a new module, and I'm going to set up the cloud key API key, and you're going to see now. Okay, there's a whole lot of stuff there, and okay, yeah, there's a lot of junk in there. I could get rid of all those /u zeros, but the important point here is it's telling me the tags and the classes that we were using. Right, I'm getting all the information that we're setting up. It's my way of debugging. So when I click update temps, we're getting a status broadcast saying these are the temperatures that we updated. So status updated, use it a lot, and yeah, it's really powerful. Pardon?
Henrik's made a point about putting breakpoints in the block diagram.
Yeah, Henrik's saying if you put a breakpoint on your block diagram before running the application, then that breakpoint will force the block diagram to open and stop in each clone. Then you can run it kind of debug mode. I think that still works. I guess, yeah, yep. But what I guess I'm showing you here as well is once you get to that executable stage and you're trying to see what's happening. Now, another really important point about what I'm doing right now is an important debug tip for everybody is, just like I've done here, I've got the one module, I've created an exe from the tester. And quite often what I'll do for these real-time projects I end up doing it at some point in the project, so I probably should just do it from the beginning. I create an exe for each real-time, for each module, and just you can run that module in its own in isolation, just like I'm doing right now, and you can test this module as a deployed module running as an executable, not in the development environment, to make sure that your module is going to stack up and run okay in the deployed environment. All right, another tip is data file transfer. There are a number of different ways you can do data file transfer. My experience has been with WebDAV of recent projects. To use WebDAV, you got to make sure your WebDAV server is installed on your target, real-time target. Then you want to create a LabVIEW application using the WebDAV client functions on your Windows computer, or you could use a third-party WebDAV client as well. Things to be mindful of: be sure to keep track of what files you've already pulled down. I had an issue with a recent project. I'm just constantly just checking. Oh, there's a whole lot of files there. I'm pulling them down, but then those files aren't being deleted. So next time around, we go and just pull those same files down again. It's a little bit inefficient. So the WebDAV client, I think, needs to keep track. Oh, I've already pulled that file down. I'm not going to pull it down again. Another thing to be mindful of: do not pull files that are still being written to. So let's say if you've got a data acquisition application and you're creating a TDMS file every 10 minutes, maybe give it 15 or more minutes before you decide it's time to pull it down. There is a delete function in WebDAV client, but I found it to be unreliable. I don't know if it's probably was just me, but I decided not to use it in the end, and it was safer to have the real-time target manage its own disk space. The little image I've shown you here, these are the settings, the WebDAV settings. So the data directory on the Rio, the Windows local directory, the IP address, the Rio name, admin and password, how often you want to go and check, how often you want to have WebDAV checked for files, how old the file must be before you download it, these sorts of things. There are other methods other than WebDAV. Systemlink files works really simply. And there's now SFTP in LabVIEW 21, which I have not tried on real time. I have used it already on Windows, but not in real time. So WebDAV is not a bad option for data file transfer. Disk management is another thing, which is just a general real-time tip, not necessarily DQMH, but my suggestion, all our wide-in apps now monitor disk usage. Each time we create a new file, we're monitoring for disk usage. There's limited space on a compact Rio, normally got about 4 gig, if that. So I highly recommend, if your target supports it, getting an SD card or an SD drive or a hard drive if you want to capture more than 4 gig of data or have it retained. One of the projects I did for a recent customer, they have a hard drive there so that if the network dropped out, we're not going to lose any data. Everything just gets written to a solid state drive. And then when network comes back on, I've got a WebDAV client constantly checking every 5 minutes or so what files are there. It pulls down those files and we don't lose anything. And then eventually the compact Rio manages its own disk and it can delete the oldest files, which is what we've also built into our wide-in projects. Wide-in has a disk management mode that auto-deletes the oldest files once we exceed a threshold. So that's what the configuration control looks like. So once it gets above 2.2 gig, we'll start deleting the oldest file. And that's really helpful for just making sure that compact Rio just keeps running forever and ever. Deployment tips. I said before, use each API real-time tester as the top-level VI and create an executable for each module, like I did before in my example with the network comms. Really good way to isolate each module and verify that that's working as a deployed module. And I just said all that. Also, I haven't tried this, but you can create a Linux real-time virtual machine and deploy your code to a virtual compact Rio or a virtual real-time target, which I think is a really powerful concept. I just haven't had an opportunity to try it. We're almost there, guys. Keep your project clean. That's another tip for you. How do you do that? First of all, start with running the validation tool, like we said earlier. Make sure that all the issues are fixed. But really important point, don't leave in your libraries and in your deployed code broken VIs, because you get caught out. It might run fine when you're running it in development mode, but then when you build an exe and you deploy it, all of a sudden the VIs are broken. And they're an awful thing to try and track down. I had an experience a couple of years ago. We were using the state diagram toolkit and it all ran fine. And then as soon as we deployed it, it didn't work. And we went through everything. We thought, we tried different versions of LabVIEW, all this stuff, and nothing fixed it. What it was, the state diagram toolkit had some broken VIs in it that we weren't using, but when you deploy that state diagram, it brings all that broken stuff with it, and yeah, so it's broken. Now, one tool to make sure you haven't got broken stuff is the VI analyzer. Get into the habit of using that. All right. And that's pretty much the end of my presentation. So for those who thought it was too long and didn't watch, DQMH works well on LabVIEW real-time. Make sure everything's at least DQMH 5. Singletons are easier to debug, but that doesn't mean clonables aren't useful when required. If you're going to use clonables, status updated broadcast is your friend. You can't use subpanels on real-time, so don't pack too much into one front panel. If real-time target doesn't have embedded UI, the RealTime API Tester and remote panel server are useful. Keep monitoring your disk usage. Delete your older files once the data folder exceeds a limit. Systemlink offers some really easy and cool UI options. Keep your project clean. Be mindful of which API tester you're maintaining. Building them into small exes is a good way to isolate the issues. Engage IT to make sure you're not going to get blocked by firewall and comms issues. And keep your structures simple. Less layers equals less headaches. All right, here we go. That's my presentation. My team is in here with me, so you can come on a bit louder. Any questions? Both live or remote? Thanks, Sam. Sam is clapping. He just can't hear me. Thank you, Sam. Thanks, Irvin. I have another million other ideas that I could talk in here, but I had to pack it down. We got a question from Kurt. Cheers, Kurt. Hey, Chris, is it possible to build the DQMH module as PPL for real time? I believe so. Yeah. There is I'm glad you asked, Kurt. I was watching a video by Matthias Bordeaux on at the GLA DevCon #1. Check it out. It's all about PPLs. He says in that that you have to. There's something about if you're going to deploy it to Linux. I don't know if that applies to Linux real time though. But you have to rebuild it to be deployed for either different operating system. But I'm pretty sure it should work. I haven't heard that you can't. Daniel Press is saying operate debug application can work pretty well too, as long as you compile debugging version. Yes, I've used that. So you can debug your application. Because DQMH distributed though, I mean, you can get caught out. You have to be very specific about where you're going to debug down into. because it's not all statically hierarchical, a DQMH project. Any questions, Kim?
Yeah.
Yeah.
You were talking about building the testers into X's.
Yeah.
I'm assuming you need to build your actual module into an X as well in order to test those together like that. Is that right?
No. Kim's asking if you're wanting to build your tester into an XE or a module into XE, you've got to build the module as well into an XE. No, you don't have to. It's what you're basically doing is you're treating the tester as your top level VI, and it's dynamic, it's statically linked to the DQMH module, so it just becomes part of your solution. So when you build the tester for a particular module, it sucks in that module. And yeah, so you don't have to build the module as a separate XE. You just build the tester as an XE. You could just build the module as an XE as well, but it's much more powerful to use the tester because of the debugging capability and the ability to run and start and stop it. Or if you had clonables, you could actually fire off multiple clones. I don't know, one thing I haven't tried is if you've got a clonable module and you want to have that as a user interface through the remote panel server, I'm not sure that you can do that. So I'm pretty sure you can't. Yeah. So this was all brought to you by Wired in Software. We're based in Melbourne, Australia. We're an alliance partner and a DQMH trusted advisor. And if you haven't heard or listened to it yet, and you're into DQMH, there is a podcast. Just hop on over to the Wired in Software website / the DQMH podcast and have a listen. If you want to continue to listen to my dulcet tones. But yeah, while we're sitting here, thanks to the GLA Summit organisers, Tom and Ollie and all the gang there. Sorry, I don't know everyone's name off the top of my head. And thanks to the sponsors as well, NI and JKI, I think are sponsors. So brilliant work from those guys. Yeah, thanks, Ruchi. Oh, Karina's here. G'day, Karina. Cheers, Kurt. All my friends are here. Yay. Thanks, William. Any other questions? Parag? No? Scott? No? Stuart? Thanks, Chris. Today we're doing we're all in here, just sitting here enjoying the GLA Summit as a team. It's been really good so far, although I haven't really been paying attention much because I've been worrying about getting this right, but now I can sit back and enjoy it. I don't think there's not an after session like last year, is there? No. Does anyone know? I forgot to do a poll this year. Could have done a poll. Any other questions? Does this make you more confident or to use DQMH for your next real-time project? All right, William's saying we can just hang out here, although I'm sure a lot of people probably going to want to listen to someone else.
A quick wrap-up of the pros and the cons, just a quick summary of the pros and the cons of using DQMH for real-time.
Pros and cons, all right, put me on the spot. Well, the pros is you get to keep using DQMH, and I love DQMH, and I want to use DQMH wherever I can. So that's a big pro. You can use it on real time. Because we use DQMH with everything, we've got a lot of templates, and we know how DQMH works. So that's a big upside. We can put together an application or get an application up and running much quicker. Code reuse, absolutely. The con is, the debugging aspect, in Cloneables, but we've learned to work with that. I mean, 2 or 3 years ago, we embarked, well, no, 4 years ago, we embarked on a real-time project, and we were talking to Fabiola about it. And I think because of that, Fabiola created the real-time tester. So it was because of YID trying to do a project in real time with DQMH that she goes, oh, what are we going to do? So she actually created it. I think Jörg from Hamplesoft was thereabouts at the same time. So it was probably because of both of us trying to work it out. So yeah, 2 or 3 versions ago, it was pretty challenging. But it's a lot better now because you don't have to strictly use clonables, so you don't have to create a workaround if you want to use singletons. That's all been resolved. The tester is much better. Yeah, and it's just a good platform. I mean, you want to be mindful of optimization or determinism. Real time is meant to be deterministic, and you know, if you want something that to have very tight timing, you got to be mindful that, you know, there's events and queues and all these things flying around, and they're not particularly deterministic. So if you've got very specific timing requirements, you got to be careful that you don't, that the general dynamic nature of DQMH doesn't disrupt that.
It's got a limit as to how
Yeah.
far you can go with it.
Yeah, you know, I mean, back in the day when I was coding up compact field point, you know, you didn't use a queue, you used a real-time FIFO and things like that. So that, and you said, hey, I need 100 elements in my FIFO, and so it would pre-allocate that at the beginning, and then you're writing and reading on a FIFO. You're not using a queue, because every time you in queue or DQ, it allocates and deallocates memory. So yeah, that's something to be wary of when you're doing a real-time application. If you've got really tight timing, deterministic, that needs to be deterministic and no jitter, just you got to be mindful.
What about commenting on the project with, you know, the testing the images that were spinning on the disk with holes, CCL?
Yeah, well, a lot of
Just commenting on that project and how you did a certain part of it in RT code, but you still used DQMH, right?
yeah, absolutely. Kim's just asking about a project we did recently. Well, Kim, that project, this whole presentation is half of that's come from my experience of trying to do that project. Yeah, because trying to debug it, the whole example where I said I had a module that I pulled across that was DQMH4, ran fine when I was in the development environment. As soon as I deployed it, it didn't run. So a lot of these ideas that I've presented to you is to try and get around that, making sure it's up to date and using the testers as debuggers.
Talking about that, you know, where you've got part of your application's got to have that tight timing for generating the pulse trains, and the other part's doing the general.
Yeah, okay. So with tight timing, it's a good point. So I had to be really have a strict timeline. What I did, in one of my modules where I'm doing a lot of image processing and it needs to happen fast and it needs to be deterministic, I created a helper loop to manage that. And I actually put that helper loop inside a time structure, a timed while loop rather than a normal while loop, so that I could, because when you use a time structure, and I was almost going to talk about this, but I sort of ran out of time, or needed to, there was too much info. But yeah, with that time loop structure, you can set the priority, you can specify execution thread, I think. So you can use some of those advanced features to optimize and improve your efficiency. And then also some of the specific sub-VIs that needed to do processing and be the most important thing at that point in time, you can set that VI to time critical priority. So you can go into the VI properties and set that VI to time critical, so that when that VI is called, it's the main thing that happens. Everything else has got to wait. That VI runs and only that VI. So I haven't applied that much lately, but for that I did. Yeah, and that was really, it just, I can't remember if it made much improvement, but it kept it together. Yeah. But anyway, it's 2 o'clock, so unless anyone's got any further questions, we might call it a day and you can go and watch the rest of it. Thanks, everybody. Any final words? No? All right. We're going to hang up here, guys. Have a great rest of the summit. See you next year. Cheers, Kurt. All right. We're hanging up. Bye.